Okay, this is section 3.4b, medians, centroids continued. So remember with our median and our centroid, all these properties exist. So we have to worry about these relationships. So AP is equal to 2 of the PEs, and vice versa. EP is equal to half of AP. And then for the whole thing, we know that AP is 2/3 of AE, and EP is 1/3 of AE. So those are the relationships we're going to use. Also with our sides, remember we have the midpoints. So in this first triangle, S, T, and U are all midpoints of their sides of our triangle. So, I'm just going to start with putting our segments lengths on the triangle. So SR is 21. So that's this whole thing. VU is 8. So this little one's 8. And PT was 15. So with SV, we know that that is equal to 1/3 of 21. So it is 7. With VR, that is 2/3 of 21. So we have 14. QR, so remember our relationship is for QV is equal to 2 of VU. So 2 times 8 is 16. Move these over. For QU, we know that that is going to be, so if this is 8 and this was 16, so QV plus VU, that's going to give us 24. PV, so that is equal to 2/3 of our 15. So 2/3 of PT is 10, and BT is equal to 1/3 of P. Sorry, BT is equal to 1/3 of PT, so 1/3 of 15 is 5. And then you can double check because we know that 10 and 5 is 15, 7 and 14 is 21, 8 and 16 is 24, so we're good. In number 2, so in G is the centroid of ABC. We know that BF is 72. So I'm going to zoom in and write all this stuff down. So we know 72 is for BF. AC is 64. And GE is 27. So first we're trying to find AF. So AF is going to be equal to half of AC. So half of 64 gives us 32. So this is 32. We know that same thing applies for FC, so this is also 32. BG is equal to 2/3 of BF. So 2/3 of 72 gives us 48. Zoom back out so I can see all of it. Next, we're trying to find GF. So GF is equal to 1/3 of BF. So 1/3 of 72 is 24. So 72 divided by 3. AG, we know AG is equal to double GE. So 2 times 27 is going to give us 54. And then AE is equal to AG plus GE. So 54 plus 27 gives us 81. And if I went too fast, remember this is a video, you can pause it. We got 3 left. So T is the centroid of triangle MNP. So TN is 16. MQ is 23. RP is 18. And that's how we got so far. So for QT, so if this one is 16, this is going to be half of our 16. So half of TN. So half of 16 is 8. And then QN is equal to TN plus QT. So 8 plus 16 gives us 24. QP, so remember this Q is our midpoint, so these segments are equal, so this is 23. MP, so MQ is equal to QP, and we know MP is equal to MQ plus QP, so 23 plus 23 gives us 46. RT is equal to a third of RP, so a third of 18 gives us 6. And TP is equal to 2/3 of 18. Oh, 2/3 of, let's use the letters. 2/3 of RP. So 2/3 of 18 is 12. Okay, next one, H is the centroid. So we know that our properties apply. So DF is 50. CF is 42. And BH is 22. So HE is equal to half of BH. So half of 22 is 11. EF is equal to half of DF. Remember, this is cut in half and E is the midpoint. So half of 50 is 25. HF is equal to 2/3 of our segment CF. So 2/3 of 42 is 28. DE is equal to EF. So this is also 25. CH is equal to 1/3 of CF. So 1/3 of 42 gives us 14. And our last one, we're looking for BE. BE is equal to BH plus HE. So 22 plus 11, so 33. Okay, and our last one. So we have to plot our points. So let's start with plotting. So A is at 110. So go over 1, up 10. So right here is A. B is at 5, 0. So right here, this is B. And C is at 9, 5. Okay, so connect your points of your triangle. So this is triangle ABC. Now to find our centroid, we need to find midpoints. So the midpoint formula, remember that's x1 plus x2 divided by 2, and y1 plus y2 divided by 2. These are going to be points. So for the midpoint of AB is 1 plus 5 over 2 and 10 plus 0 over 2. So I'm just using their coordinates. So this is 6 over 2 and 10 over 2. And reduce, we have 3, 5. So that's a really nice one. So that's one midpoint. We call this D. E is the midpoint of BC. So 5 plus 9 over 2 and 0 plus 5 over 2. Reduce this, we have 14 over 2 and 5 over 2. So this gives us 7 and 2.5. Oops. So that's 1. And then I'm going to throw the other one away up here in the top because I'm running around. So the midpoint of, so let's call this F, the midpoint of AC. So using points A and C, we have 1 plus 9 over 2 and 10 plus 5 over 2. So we have 10 over 2 and 15 over 2. And finally, we have 5 and 7.5. So those are all of our midpoints. Now we have to connect them to the vertice on the opposite side. So connecting this one to the vertice on the opposite side. So right here in the middle, that is our point. So we are at 5, 5. That's our centroid. So we connected our midpoint to our vertice, to our vertex. So AE, DC, and BF. And where they intersected is our point.